Hi everybody, and welcome to part 2 of my 3D printers build log. This is where we stopped in the last video. As you can see, we built the frame. It's halfway done, at least in CAD. I didn't want to proceed any further because I just wanted to start building the printer. Since then, many parts have arrived, so I'll be showing them to you at first. And then, of course, I'll start building the frame. Before I start building the frame though, I want to reveal the new title or the new name of my 3D printer. I think it's pretty cool. I will call it the Transform3r. Yep, has nothing to do with the Transformers, out of obvious reasons, but I think Transform3r will be a very nice name for a 3D printer. On this coffee table I have all the parts except maybe these are all the parts that I can think of that you would need. You probably need a lot more. I've probably forgotten many things, but at least you need these parts. But it's probably better to show this in a close-up so that I can script what I'm saying and you don't have to listen to my rambling. Yeah, let's do that. Since I have a lot planned for this video, I'll only go over the mechanical parts for now. So first, let's start off with the frame. I went with 2020 type aluminum profiles. To build the exact frame that I'm building, you'll need 18 extrusions with 340mm length and another 4 with a length of 180mm. For the vertical posts, you'll need 2 double extrusions of 300mm per corner, totaling 8 of those. There are many websites and eBay vendors that sell those aluminum extrusions pre-cut to the size you need. Unless you really want to cut it yourself, I would highly suggest ordering professionally cut ones, especially since the price premium for that is pretty much zero. There are many ways to connect the extrusions, but I think the cleanest way is to use standard end fasteners and angle connectors where the extra rigidity is needed. The downside of the standard end fasteners though is that you'll have to tap the end of one extrusion and bore an access hole in the opposing extrusion. But I'll show you how to do that later on in this video. If you don't like to tap and bore into the aluminium, you could also just use angle connectors instead of the standard ones. As for the base of the Transform3r, I again went with a pre-cut sheet of 5mm aluminium of 450 x 450mm. 5mm is actually pretty thick and the sheet is pretty heavy as well. But it will make the printer very strong, and due to the thickness I'll be able to tap threads in it if I end up needing it. The XY movement system will be suspended on 8mm diameter hardened steel rods with a length of 350mm. I'll be using a standard GT2 timing system with 7 8mm inner diameter 36 tooth pulleys and one 5mm inner diameter 36 tooth pulley to attach to one of the motors. You might have already asked yourself what that white roll is about. That's actually a 5 meter long GT2 timing belt. I've never seen white timing belts before and I think it looks amazing. As the YouTuber Tech2C already showed in his build, carbon fiber rods are pretty nice to use if they are part of a moving system, since they are extremely light. I also really liked his idea of using linear bushings instead of linear ball bearings and got some 8mm Equilidor bushings from Aegis. I'll have to experiment with those a bit more, but I'll definitely keep you updated. I've already pointed out that I'll try to use drawer slides instead of linear rails for the Z-axis, and I don't know if this will work, but the idea really bugs me, so I'll have to try it. I bought 20 slides of 278mm length, although you'll only need 16 in total. The way I designed the Transform3r, I could easily just convert it to a normal 3D printer if it turns out that the transforming feature just doesn't work. I guess the only sad thing would be that the name would be obsolete and I would have to think of a new one, but let's not think so negatively so early into the project. Some other parts you'll need are 8 ball bearings of the type 608, which can usually be found in skateboards. Then you'll need 3 5mm to 8mm couplings and 2 T8 8mm lead screws with a 2mm pitch and a copper lead nut each. I don't know the exact length that I'm going to need yet, so I bought long 600mm ones. And as I said before, I don't want to bore you any longer with my shopping haul, so I will talk more about the electronics once I start using them in a later video. But for now, let's start building the frame. To connect the aluminum profiles together right here, I'll be using standard end fasteners, which is this. And how you connect it is actually pretty simple. You first have to tap a thread right here into the hole where the screw will fit in. And then you take this clip, you insert the screw, and then you can slide this into the opposing part, like so. And then you'll be able to screw it in right here. Now you might think, how will I be able to screw it in right like this? Because, I mean, I can't access the screw itself. Now that's actually also pretty simple. What you have to do is make one more hole in the backside of this one, so you can access the screw on the other side. First I'll be showing you how to make the access hole right here. So what you do is you just eyeball where you want the hole to be. And then you take a screwdriver. This is or something. Better would be a normal center punch, but I don't have one. So this is a screwdriver for the Nintendo systems. I don't need them anymore, so I can just use it for this. And you look where you want the hole to be. So this spot would be pretty much perfect. And then you take a big hammer and give it a whack. Okay, easy peasy. Then you take a drill and just go at it. So there's the access hole. And there's a hole in my table. Perfect. And it's pretty clean. So now we can easily just take the standard connector, slide it in like this, and access the screw from the opposing side through the access hole. The only part that's missing right now is the thread on this side. For that you need a tap. You'll always want to start with the coarsest thread because it's actually the smallest in diameter, and then go over to the medium thread and then the finest thread, which is the biggest in diameter. So what you want to do is just insert it pretty straight and then slowly work your way down. It's getting harder to grip the profile. And then back out again. You could also do this with a screwdriver, but unfortunately my tabs won't fit in my screwdriver, so I'll have to do it by hand. So now everything is prepared. You just take your screw with your bracket, put it into the profile where we screwed made the access hole right here. And then you take the profile with a tapped screw and connect them like this. And then you just go through the access hole and screw them together. actually take quite a bit longer than anticipated. I didn't think that boring all those holes and tapping all those screws would actually take so long. Of course, the task itself was very easy, but I mean, it were just so many holes to bore and to tap that yeah, it did take quite a bit longer than I thought it would take. But anyways, the frame is built and I'm pretty happy. It's very sturdy, just what I wanted, and it looks like the way I planned it, so that's a good thing. Yeah, of course, these two parts are still not attached, so I do have to install the rails in the next video. That's the first thing I'm going to do. And other than that, if you're interested in the build log of this printer and you haven't seen my previous video where I explain everything about what I want to achieve with this printer or what I want it to look like, and yeah, if you don't know what this second part is about, then definitely check out my first video on this printer where I explain everything about that. So I hope to see you in my next video where I finally will be installing these drawer slides, and until then, goodbye!